What I want to do now is give you an example of a computation of a gradient with respect to one of the w's. So let's say that we're interested in this particular w, w143. We want to compute the cost by the w143. Now, again, this cost is with respect to a single training case. If you have multiple training cases, things are slightly more complicated. Here we're just talking a single training case. So how would that go? Well, what you would say is, okay, so first we need to compute the cost by dz for every z, the cost by dh2 for every h2, and then the cost by dh1 for every h1. So h11, h12, h13, and so on. So how would that go? Here's an example. Let's say that what you want to do, and you do want to do that, is you want to compute the gradient with respect to h13. How to do that? Well, so this is the eventual goal. So what we want to do is we want to compute the cost by dh13. Alright, so this says if I change h13 a little bit, how is the cost going to change? Well, changing h13 changes this unit and this unit and this unit and this unit and this unit. So what we need to do is we need to sum up the effects of changing this guy and changing this guy and changing this guy and so on the cost. That's exactly the multivariate chain rule. So what you would say is the cost by dh13, that would be the sum over the effects on all of those times the derivative of each of those by h13. So we'll do a sum over j of dh2j by dh13 times the cost by dh2j. So how do we compute the cost by dh2j? Well, presumably we've already computed it, but it would be a similar process where you would compute the cost by dh2j in terms of the cost by dz and dz by dh2. So this is how you would compute that. Let's say that we have this. What can we do now? Well, now we can say, okay, so having this, it's pretty easy to compute the cost by the w143. So w143 is the weight that's connecting x4 and h13. You change this guy, the only unit that changes in this layer is h13. That means that all you need to do is to say, okay, that's equal to the cost by dh13 times dh13 by dw143. Excellent. So the cost by dh13, we're kind of assuming we already have that because we have the formula for that and you'd apply a similar kind of procedure to compute this. So let's focus on trying to compute this guy, dh13 by dw143. How to do that? Well, here you actually have to write things out. So dh13 by dw143, that's d by dw143 of the actual h. So we need to write the h. So this would be sigma, the activation function, of the sum over j of, so here again we're computing the weighted sum of the x's that go into h13. So it's going to be the sum over W1 because we're going in the first layer, going from xj and going to h13 xj plus b13. Great. So what's that? Well, this would be sigma prime of the same thing, of the sum over j of w1j3 xj plus b13 times d by d w143 of the stuff inside here, of this sum. So that's going to be like that.